Welcome back to BSpice. In this session, we'll discuss about a new topic, industrial communication. So basically, friends, this one I am going to bring in four parts actually. So yeah, this is one of the long pending video actually in BSpice. Some members asked for this, and I could able to spare. Okay, so yeah, so four parts in the sense. I'll just touch upon bit of intro, and also we'll talk about network topologies and OSI model. Very important to understand what is this OSI model. This three will focus in part A, this section. And also we talk about the hardware and cables used for digital communication. All cables, hardware, all these will focus. That will be in part next subsequent session. Then also we focus on communication methods, and we also discuss about interface standards and the device, all these. Then finally, we wind up with the proprietary and open protocols. So yeah, first three will focus on this session, and the fourth one will focus on the next session, and the other will focus on the subsequent session. Okay, now protocol. What is a protocol? As we all know, it's a method for digital, data communication between two or more devices or on a network. This is the definition, right? So it's basically protocol. What is protocol? Yeah, it's a method for digital data communication between two or more devices on a network or on a network. Okay. Then when we talk about network, what is the network? Network is nothing but interconnected group of computers, controllers and devices that interact with computers and controllers. So that is the point of network basically. Okay. So that's the definition of network, interconnected group of computers. Right. Then here there is a question on node. What is this node? Computer or other device in a network. So that is a node. Then topology. See, as we all know, we have three topology: bus, star, and ring. Okay. Even though you take it as a refresher, we will discuss about this topology one by one. Okay. So bus topology. So this is the look and feel. As you can see here, this is your bus topology. It's basically a simplest. This is the simplest. Note the presence of resistors at the end of the bus here, right? This is the resistor, right? So each node is exposed to traffic. You see here, one, right there. Each node is exposed to the traffic data on the bus, but it will respond only if the data is directed towards it. Otherwise, the data is ignored. That is the point. Okay. So the data will go, and this guy will respond only if it is directed towards it. Otherwise, it will just ignore. Okay. So the disadvantage is that the failure of the bus cable will stop the communication. Obvious. Yes, right. So end resistor with identical resistance are used to improve the signal quality on the bus. This is the point we need to note. So this is all about the bus topology. Okay. Right. So yes. And one more point. Yeah. Here, point to point connection, that is connect a PC and a single printer, is the simplest example of bus topology, right? So connecting a PC with a printer is the simplest example of bus topology. So this is all about bus topology. Now we'll see about the star topology. As you can see here, the look and feel, yes, this is the star topology. Okay. In star topology, individual nodes are connected to a central node. Individual nodes are connected to a central node. So here, very often, friends, the central node is basically a switch, right? Okay. So the switch allows temporary pathways to be made, so any node on the network can communicate with any other node. Okay. So, yeah, I think this is a typo error. Communicator. So the switches actually allow temporary pathway to be made. So any node on the network can communicate with any other node. Okay. So the individual node can be disconnected. Okay. Without affecting the communications on the rest of the network. So that is the another beauty. Okay. So this is more reliable than bus topology. Okay. So here all traffic stops if the central node fails. So that is the drawback. If this fails, then everything goes. Okay. The switches here, are inbuilt. But yeah, see, we are saying it's a drawback. But the thing is here, the switches are built for high reliability and often UPS, the uninterruptible power supplies are connected to provide temporary backup in the event of loss of line power. So that is the beauty. Even sometimes, redundant switches also used to improve the reliability. In that case, each node has two ports actually with separate cables attached to each distributed node actually. So that is how the star topology works. Okay. So redundant switches are used and each node has two ports with separate cables. We'll have two ports and separate cables. So thereby the redundancy is ensured. So we can say it's reliable than bus topology. Okay, friends? Right. So that's all about the bus. Sorry, ring. Okay. Sorry. That's all about the star. Now we'll focus on the ring topology. Okay. So this is the look and feel of the ring topology. Here, friends, the ring doesn't need to have a master. No need to have a master, but usually it does, but generally don't have, no need to have. Each node can send and transmit data. Okay. So data sent from one node to another is forwarded around the ring from the originating node to the destination node to which it is addressed. Okay. So that is how it works actually. Okay. If the segment fails, the data can be sent in reverse direction. One segment fails, it can be sent in the reverse direction. So the double ringer, this is another typical, provides enhanced reliability. Okay. So this is about the ring topology. Okay. Now we go into the OSI model. This is actually, before going into the OSI model, I want to also give you some, concept, friends, related to this communication. Okay. As you know, friends, most network have a central computer known as server, right? Correct? Yes. Okay. So what I want to say is here, the servers are computers which meets a higher standard for dependability, durability, and speed of access to data than the ordinary desktop computer. Okay, you got it? So typically the server have large data storage. Okay, and of course the servers are frequently set up in a redundant path. Okay, so that is what I want to inform you. Okay, maybe one more thing. The client, all these client server, this also I want to touch upon a bit here. Friends, computer in a network which act only as a dumb terminal which operators can use for monitoring and control, right? But don't directly interact with the controller. Okay. So these are referred as a clients. Okay. Right? Yes, it's a client. A server process the request from its client. Okay. A server process request from its client and interact with controller. You got it? Yes, the server process the request from its client and interact with controller. Okay. So here the main point what I want to inform you is this is just an add-on notes, friends, add-on notes, just for sake of, just for knowledge. Okay. The server often referred to as a thick client. The server is referred to as a thick client. And client PCs are sometimes called thin clients. You got it? That is why I want to inform you. Okay. So basically, these networks work on a client server configuration. Okay. This is what I want to inform you. Okay. Then What else? Yes, I think good to go. One more concept also. Have you heard about, in the communication, you talk about this half loop duplex and full duplex? Yes. So that is what I want to uh, friends, some communication cable have a one group of conductor or a fiber for communication in one direction and another group of conductor or fiber for communication in other direction. Regarding such cable, two communication terms are used actually. What are the terms? This is what half duplex or full duplex. What is half duplex? Half duplex refers to the transmission of data in only in one direction at a time on a cable or other data link. Full duplex refers to the transmission of data in two directions simultaneously. That is the point. Okay. Just want to know, update you. Okay. Now we go into the main business, OSI model. So OSI is nothing but Open System Interconnect Model. Okay. So, friends, this OSI model is a theoretical model of how communication occur on a network, right? It has a seven layers. It has a seven layers, right? Yes. So the layer one is a physical layer. As you can see here, this is the layer one, physical layer. So the layer one basically, you know, consider the physical aspect of the network, meaning cable, converter, interconnecting devices. Okay. So this is layer one. Then layer two is a data link layer. Okay. This layer concern itself with how layer one and three work together. So what is this layer one? Physical and layer three network. So this data link actually concern itself with how layer one and the layer three work together. This is the data link. So that is what. Then layer three is a network layer. Basically, it provides an addressing scheme for routing the data and messages and include a method for reliable data communication. Basically, this is a provides an addressing scheme for routing the data and messages. Okay, layer three, that is network layer. Then the layer four is a transport layer. This layer ensures that messages get to their correct destination. That is why it's the term transporter. Okay. Then layer five is a session layer. So this layer handles the actual connection between the system. Layer 5 handles the actual connection between the system. Okay. This is basically a session interhost communication. Okay. Then layer 5 is 6 is basically a presentation. So presentation in the sense, this deals with the way of different system represent data, representing the data, including the encryption, all those. Okay. Then final layer 7 is the application layer. So this gentleman concerned itself chiefly with the software application used on a computer screen. Okay. That's it, friends. I hope you had a very good insight on this protocols and the topology and the OSI model. It's very simple. I know that. Yeah, but many more is there. Next session we'll talk about computer and what do you call them? The hardware basically. Hardware and connecting cable. We'll talk about the computer and control and network devices, standalone network devices, and some network communication cables. All those will focus in the next session. Stay tuned and thanks for watching and show your support, friends, either by subscribing or pressing the thumbs up button or if possible become a member. Thank you. Take care. Bye.